Sıradaki konuşmacımız Juergen Niethammer, CommScope'dan geliyor. Kendisini alkışlarınızla sahneye davet ediyorum.
Good morning. My name is Juergen Niethammer. I'm from CommScope. We are an international manufacturer of fiber optic cabling systems for data centers. And the presentation I have here with me is about AI. AI in general at the beginning, to give you an overview about what AI could mean for our life. And then we talk a little bit about AI back-end networks. That is the networking part inside a data center that is giving you the AI functionality. We will see how that is built and what is different compared to normal cloud data centers. So this is, as a kind of introduction, how a lot of people look at AI. When you look at the evolution of the human mankind, there were always so-called technology waves, innovation waves. You know, for example, there was, the steam power, the steam machine where, do I have a pointer? Yeah, you don't see it. So the steam power came, and then the cars came, electricity came, electronics came, and the innovation and our life was better through all these innovations. And now what people say, we are now at the start of the sixth wave that you see all to the right, which is mainly about AI, robotics, drones, and clean tech. So that's the area, innovation area we are now in since 3 or 4 years. It's called the sixth wave. And AI is the core driver of this sixth wave. AI will be part of our life in many, many areas. AI will, for example, be used to do resource optimization and to drive sustainability by enabling smart grids and resource optimization, like I said. It will be part of a maybe completely new education system, where education is available all over the world, done by AI, so everybody, no matter where he is, no matter how much money he has, he can access the AI resource to do his education through it. It will have a big impact, that's what people say, on healthcare and life science by, finding new medicine, doing precise medication, for sick people. So it has a lot of impact on a lot of different areas. And last but not least, of course, it will also drive different business models for enterprises, very much data-driven, very much service-oriented. So that's all what we can expect from AI. I know a lot of people that are a little bit afraid of AI because I know a lot of people actually have the fear that AI will take away the job. That might be, and that has always been like this. Whenever one of these waves came, people lost a job because a machine could do it, and it will be the same with AI. But what I think is that, and I'm reading a lot about that there will be new jobs, that will be mainly on the sustainability side and on the side of managing AI. So there will be new jobs available so that people that lose their job can, re-educate to have another job. I was actually, I experienced that in the late 70s when I was tired of school and I decided to learn a job, and I learned to repair typewriters, mechanical and electric typewriters. And I decided to do that, I did it, and 5 years later somebody came and invented the personal computer, and suddenly nobody wanted to use a typewriter anymore. So I had to re-educate to be more a computer specialist than a typewriter repairman. But this is the way it goes, and this will be the way it works with AI. But at the end, I think we will all have a better life through this. It's just a transformation phase that we have to go through. If you listen to people like Elon Musk, they even go a little bit further. They say, maybe at the end, when AI works well and we use it in a very good way, maybe not, we don't need to work anymore because all the robots and all the AI can do the things for us that we used to do. I don't know if I want to go that far. I always think about, okay, how do we earn our money then when we don't work? How is that working? So I think there will be a lot of changes in the society and the way we live together because of AI. But that's very philosophic, and that's not part of the presentation, so I just want to give you some food for thoughts. But it will be big, and I have something here that shows you actually how big it is from a financial perspective. So this is from Brookfield Investment Company, a Canadian company that is doing a lot of investments around the data center, and they say that for the next 10 years, AI will be a $7 trillion investment opportunity, which is massive. Yeah? That's 7,000 billion. That's an unbelievable number. And you see where that money goes. Here in orange, you have the compute infrastructure. So that's actually the IT that is doing the AI. That's the GPUs, the chips, the servers, and all these things that actually do the AI compute work in a data center. That's the biggest portion. And here you have the 2 trillion. These are the AI factories, actually the data centers. So somebody has to buy the land, build the data center, bring the infrastructure in, like the cooling, like the power, and all these things. And then you have power and transmission. That's the base load of that data center. So just to give you an example, I was in the Middle East 2 weeks ago, and they're building a data center near Abu Dhabi as part of the Stargate project. Maybe you heard about that. That is a US development around AI, and they have one in the US, but they are building it in other regions as well. And they talk about a data center that has the size of 4.6 gigawatt, not megawatt, gigawatt, 4.6 gigawatt. They're building a nuclear plant next to the data center to power it, just to give you the feeling how big that is and how big the investments are. Our part, so the CommScope part, is in that blue box where it says dedicated fiber connectivity. Still a very big business for every cable manufacturer. So that was a little bit as an introduction to show you what AI will do for us. In terms of a society, in terms of technology, in terms of innovation. You have seen the investment, how much money is going in there. And now we talk a little bit about where is AI? So where is the AI hardware? Where is the functionality of AI? Where is it sitting? And I'll show you where it is in a second. I just want to pave the road to start with the cloud data center. Let's say there is an existing data center that is a cloud data center or an enterprise data center. They look pretty much the same. You have a wide area network access on the top. That means that is where the data center is connected to the internet and where the users come in to use the functionality of the data center. Then you have a network here. Spine leaf switches, those are Ethernet switches that do the data transmission in the data center, and then you have the servers that do all the compute. That's a traditional data center. They are all built like this somehow. You know? And the protocol that they use here is called Ethernet. Ethernet is probably 99% of all data centers use Ethernet. So when you want to add an AI functionality to this data center, what you need to do is you change the servers, the CPU servers, to so-called CPU and GPU servers. So they need to have the GPUs. The GPUs are the working horses for AI. They are much higher performing than CPUs because they come from the graphical side, graphical processing units. They have 10,000s of cores, and they do parallel computing very, very, very quick. So every AI server in the world has GPU. And you see it also has CPUs. Why? Because the upper part is now called a front-end network. This is still the same. It's exactly the same as on the left-hand side. So the CPUs are connected to the front-end network using Ethernet. And then you have the GPUs that are connected to a so-called back-end network. And this is actually two networks. It's an internal, system-internal GPU fabric that allows multiple GPUs that are in one system to talk to each other without going out of the system and using Ethernet. So it's a system internal network, and we have the switch network in the back. That is the external, the scale-out network to combine different systems. And in that back-end network, we see two applications, Ethernet, or we see InfiniBand. InfiniBand is a classical high-performance computing transmission protocol that is primarily pushed by NVIDIA, because NVIDIA bought a company called Mellanox some years ago, and they are the market leader in InfiniBand technology. So you see these two applications competing in the back-end network. A lot of people say in some years Ethernet will dominate that, because more and more vendors push Ethernet. They even optimize Ethernet now to close the performance gap to InfiniBand, and it's much cheaper than InfiniBand, so that's why people think in a few years it will only be also Ethernet in the back-end network. The challenges that this back-end network brings, not the front-end, the back-end network, are listed here. So you see, the network speed is probably times 8, times 16 compared to the front-end network. You have probably 20 times more fiber in that back-end network than in the front-end network, and you probably have 50 to 60 times more power that these systems require for that data center. And I will give you examples and give you an understanding where that all comes from. These are the challenges that you see in the AI backend networks that need to be solved. Let's first have a look at the network bandwidth. On the front-end network, maybe not easy to read from behind, but what you see here, this big gray thing, that is 100 gigabit per second. This is mainly the speed between the switches here. I call it the backbone speed, and probably you have a server on the CPU side. You probably have a 25 gig or a 50 gig connections, but you have a 100 gig or a 200 gig fabric bandwidth in the front-end network. When we look at the back-end network, you know, the first generation that really was, you know, came from NVIDIA and was the one that is still used and used in many, many cases in many, many data centers, the DGX H100, that started with a 400 gig already. So it had an 800 gig port, and you plug in an 800 gig transceiver that has two ports, 400 gig each. So you have factor 4, or actually factor 8, in the speed of the backend network. And you see how this will evolve. In 2027, beginning of 2027, IEEE will define 1.6 terabit as a new speed, and then you immediately see how this will be used. Then they will use 1.6 terabit transceivers with two ports that have 800 gigs. So the speed increase compared to the front-end network is very, very high. AI data center back-end networks always use the latest technology. They are hungry for more bandwidth. This is the evolution of Ethernet. By the way, I started with the company in 1994, and 1 year later, in 1995, fast Ethernet was defined, 100 megabit. And everybody was saying, well, that's too much. Coming from 10 megabit, people say, we will not need that, never, we will never need that. Yeah? Now you see where we go, you know, there was gigabit times 10, 10 gigabit times 10 again. Now we are here, so you see speed in development is 1.6 terabit, and the people talk already about 3.2 terabit. So the speed increase, also mainly driven by AI, is tremendous. These new speeds have impact on the connector technology that is used. So if you look at the applications in that orange box up to 100 gigabit, they were using a decoding, a modulation system, or a scheme that is called NRC, non-return to zero. And that was used for lane speed from 25 gig and less. That was up to 100 gigabit. And above 100 gigabit, that changed, and they had to use a coding called PAM4, from 50 gigabit per lane and above. So 200, 400, 800, everything that's coming now is using PAM4 coding. And you see the difference here in this picture. So what you see here is the eye diagram from a transceiver. So the transceiver sees this, and it has to have this distance here. That's the signal to noise ratio. This is a clear eye that you see here that the transceiver needs to decode the system. When you look at the PAM4 coding, you see that there are 3 more, because it's a more complex coding. And the signal to noise ratio is now 1/3 of NRC, so that means that the transmission channel, the cabling channel, has to be very precise and very well performing, otherwise the transceiver cannot decode the system. And when we talk about AI networks, we talk about MPO cabling, multi-fiber cabling. So there's no LC duplex anymore, it's all MPO. And what they do in the single mode, when you look at an MPO single mode, that's always APC, that stands for angled physical contact. So that means that the end face is not flat, it has an angle. And why? Because if there is a reflection, so if I put 2 connectors together and they are not well done, let's say, or there is dirt on it, reflection can cause. So there is the signal coming, and at the point of connection, it's reflected back. And in order to improve this situation, they angle it, the connector, so the reflected signal goes out of the fiber. That's how they improve the performance. Coming to the number of fibers and cables that go out of a cabinet. This is a traditional compute rack from a cloud data center. I just take an example, maybe there are 48 fibers coming to that rack to connect the switches and the devices in there. In AI, it's a completely different world. This is the first generation of AI, DGX H100, 4 servers with 8 GPUs each. Every GPU in a server, every GPU always has its own networking port, always. So we have 8 GPUs and 2 CPUs per server. Yeah, that means every server has 10 ports. Yeah? So you're already running 320 fibers from this cabinet. And this is the newest technology. It's a so-called rack scale system. So here we had 4 individual servers, and on the left-hand side, that cabinet is 1 server. So you cannot get in bits and pieces, you order 1 rack. Yeah? And that has, oh, sorry, how can I go back? Yeah. Confusing. That has 864 fibers that go out of that cabinet. You see how many fibers, how many cables somebody has to deal with when it comes to AI. And it's getting even worse, and I will show that to you because the NVIDIA GPU roadmap says we're just here This is the thing what you just said, NVL 72, that means 72 GPUs per rack. But they are going now for 144 as an interim solution, and their final goal is to have an NVL 576, which means you have one rack that has 576 GPUs. Now you know that every GPU and every CPU has their own networking port. You can easily calculate how many cables come out of such a solution, but you will see in a minute I have a slide on that. Talking now about this here, this technology. Actually not the newest one, but just to give you an example what it means from a fiber count perspective. So what I did here is I have 16 so-called scalable units. A scalable units is always here, these 10 cabinets with 32 GPUs, and in the middle you see the management cabinets with the leaves and spine switches. So that's one unit that works on its own, 32 servers with 8 GPUs each. They work to each other with other, and when you want to scale them, you have to introduce core switches. You see, this is the first level of core switches, 64. And if you look just at this configuration that has 4,096 GPUs, it's approximately 12,300 cabling links that need to be installed like this. And it's just 4,000 GPUs. The Deutsche Telekom in Germany, they just announced that they do a data center with 10,000 GPUs in Munich. And just to give you an example, then we are a little bit higher than here. And the European Union wants to build 5, they call it AI gigafactories with 100,000 GPUs each. Can you imagine how many cables that is? It's unbelievable. So here's the evolution. That's the one that I just showed you. Scalable unit, NVIDIA H100, 8 GPUs per chassis. You have 40 MPO cables per rack, and you have 42 kilowatt per rack. This is the actual state. 100 MPO cables, 8 of those NVL 72, and you see this one rack needs 120 kilowatt. 120 kilowatt. Next level will be NVL 144, that means 144 GPUs per cabinet, 220 cable, and all to the end, the final goal, you have seen that in the roadmap, is this NVL 576 that has everything that you see here in one cabinet. And people say this will maybe consume 500 to 600 kilowatt. One rack. Yeah? GPU increase times 80. Can you imagine how difficult it will be to have 440 MPO cable coming out in this from this one cabinet? From a cabling perspective, it's a nightmare. And as you see how the cabinets need more and more power, you see the power increase in data centers. Yeah? You see that within the next 3 years in EMEA, it will go from 29 gigawatt to 47. And it's the same in every region. It almost doubles the power capacity requirements. So new power need to be found, and that is a concern in many, many countries. I know, for example, in Frankfurt, they say we are almost out of power. Yeah, so all the people now go with their data centers to Berlin because there is more power available. It's really a lot of power consumption. I was reading one thing where it's saying by 2028, I think the global power that is needed for data centers equals the power consumption from Germany per year. Unbelievable number. Yeah. We from CommScope, we have solutions to put all these things together, let's say. We have cabling solutions, we have a lot of experience, we have very large customers in the US that build data centers with 100,000 GPUs. and we have some experience about how to put that together, what fits best. Most important thing, how can we cable this very quickly? Because you can imagine if you have a data center of, let's say a number, 25,000 GPUs, it takes a lot of time to install all that cabling. And the people want to do that very quickly because they invested a lot of money in these AI servers. One GPU costs around $30,000 to $35,000. Can you imagine? You have a data center with 25,000 GPUs. Calculate yourself, that's millions and millions of dollars. And you don't want to sit them on the shelf. You want to have them up and running as soon as possible. So we have solutions that allow you to install that very, very quickly. And with a good cable management that you can easily manage the whole installations. And we have one sample on our booth here. We have a booth next door in the corner all the way down there. And if you want to see our optical distribution frame, there is this one here for high fiber count installations. You're very welcome. My colleagues and I, we will be there and happy to welcome you and explain you a little bit. Sorry, I was a little bit too long. I hope you find it somehow interesting. If you have questions, please, I'm here for the next 15 minutes, but you can also find me all day on the booth. Thank you very much.